You are listening to Science Coast with Mallory Havens and
Chris White.
And today, I want to know how the universe is going to end.
Oh, it'll never end, Mallory. It'll just be the same forever and ever.
Well, I'm assuming humanity will be done way before the universe.
Yes. I think that's a fair assumption.
And perhaps the Earth before the universe?
Yes. So our solar system was created after the beginning. So the beginning of the universe was first, and then our solar system came later. And then our solar system will be no more before the entire universe goes away. Yes, that's true.
So the reason I'm asking is because I recently learned about something called the heat death, which I think it's also alternatively called...
Is that a climate change thing?
No. It's how the universe might end.
Oh, heat death of the universe.
Yes. But I also heard it's sometimes called the big freeze, which makes more sense to me than heat death, because heat death implies to me everything like boils to death. But that's not what happens, right?
So you're asking for a short lesson in cosmology.
Yeah.
So I was not in some sense joking too much at the beginning when I said it will never change, because the original cosmology was just that the universe is static and it has always been and will always be. But that is typically what people say when they really have no idea. Yeah,
and that doesn't count for the Big Bang because it wasn't there before.
Well, that was before. So yes. Yeah. So the theory or the idea, simply because people didn't have enough information and didn't know about things like the Big Bang, had no data to support that there was such a thing as a Big Bang, is that the universe was constant and it was everlasting and had always been in existence. But of course, as scientists, we're like, wait, infinities actually can't really exist, can they? In the sense that time has always been there and will always be there forever? Like really, truly infinity? So we do now believe that there was a beginning. I like to think of it as a cosmic seed where there is a point, or effectively something close to a point in space, that expanded out to become the universe as we see it. And then the question is, what happens at the other extreme? Many different thoughts. So your comment about, freezing to death, that's not always after the theory of the Big Bang came and, there's an expansion of the universe, but then there's gravity. So gravity is an attractive force. So there was a thought that the expansion was continually slowing down due to gravitational self-attraction. The universe is gravitationally bound to itself, maybe. And that the universe eventually, the expansion would slow down, stop, turn around, and then collapse down to a big crunch.
That's what I heard about the big crunch, which could result in the big bounce, which is the new Big Bang.
Well, it would just be a perpetuation of universes. So you have one universe, and then you'd have another one, and then you'd have another one, and then you'd have another one. And I guess that's where the infinity comes from, that it's constantly going through these cycles of expansion, contraction, expansion, contraction, expansion, contraction.
So theoretically, the big expanding out, then we stop at some point because I think I read, and I'm gonna.
You've been reading again, haven't you?
I know I really shouldn't do that. So, like with this big crunch, that it kind of implies that we weren't the first universe, or there could be infinite before and infinite after. But I also read about the big rip.
Yes.
Where it keeps expanding to the point that gravity is overcome by dark matter?
Yes. So before we get to the big rip, there's one other aspect of the expansion of the universe that I want to get to, and it has to do with escape velocity. So if we think about, whatever goes up has to come down, is what people would always say on the surface of the Earth. You throw a ball up and it comes down, except if you throw a ball really fast.
And really high.
And really, so it never comes back, right? So it has achieved escape velocity.
Mm-hmm.
And the kinetic energy that you impart is greater than the gravitational potential. Therefore, it never comes back. And there is the concept that the mass of the universe acquired sufficient kinetic energy at the beginning that it achieved escape velocity with itself, so that the kinetic energy of the universe is greater than the gravitational potential of the universe. Therefore, it will expand forever. And it will never go back to a big crunch. It will just continue to expand and never stop. And in that situation, if things are getting farther and farther and farther apart from each other, then you eventually live in a very lonely place. And you will no longer see any stars because they'll be too far away.
Well, you'll definitely be dead if you're not.
Well, yes, but then at the same time, the separation between all of the galaxies, the separation between all the stars, the separation between the stuff in the space is so vast that the size of the universe becomes infinite, and it's kind of boring because it's like that's not really what I want my universe to be in the future. So, extending on that is the Big Rip, where if we assume that gravity is the only force, then the only thing we have to worry about is the factor called omega. Is the gravitational potential greater than the kinetic energy, or is the gravitational potential less than the kinetic energy? So is the value of omega greater than 1 or less than 1? That's assuming gravity only. If there are other forces that we don't fully understand that are accelerating the universe, repulsive forces, that are causing the mass within the universe to repel from each other in addition to the gravitational attraction, then you can have an accelerating expansion as opposed to a constantly slowing down expansion. So with gravity alone, you should have a slowing of expansion, and if the universe is open, it will slow forever, but it'll never stop. If it's closed, it'll at some point stop and then collapse upon itself.
But didn't you tell me that the universe is expanding faster and faster all the time?
That's because the evidence suggests, the data suggests that the universe is expanding at a higher rate, which means there must be a repulsive force which is driving matter apart and counteracting gravity, almost like an anti-gravity force. And if that's...
Is that dark matter?
Not dark matter, but they hypothesized something called dark energy.
Okay.
So dark matter will behave gravitationally the same as regular matter, but dark energy has this magical characteristic that it seems to have a repulsive force associated with it, which nobody really quite fully understands.
So Darth Vader.
Yes.
Okay.
And so as a consequence, the acceleration of the universe, and it was, so the data, as we look at the data, the universe was in a period of slowing down, where gravity was more powerful than dark energy. So the universe was slowing down. Then there was an inflection point, and it seems as if the universe is accelerating again. So you have the original Big Bang, so shoots everything out. Things are slowing down due to gravity, and then all of a sudden, at some point, they start accelerating again due to dark energy, where dark energy is now dominating over gravity. And if you think about it that way, if you accelerate something, then it moves faster and faster and faster and faster. And so the universe will accelerate into nothingness because everything will be so far apart. And at some point, the acceleration will exceed the speed of light, and you have a big rip.
So do you think, okay, first of all, I just want you to note that I now agree physics is more than just how a pendulum swings. So
really?
Thank you. Yeah, I mean, it took a long time to convince me.
I start with pendulums for every class.
Because it's the only thing that matters. And balsam wood bridges. But,
well, it's kind of engineering, but there's physics there too. That's fine.
So do you think the Big Rip is more likely than the Big Crunch?
I don't know. This is one of those open questions where, they look at these Type 1a supernovas and faraway galaxies and try to collect information, and what does this mean? What does this mean? What does it mean? And they come up with ideas and theories and hypotheses that, oh, well, this is consistent and this is consistent. Well, this is not consistent, but that's more consistent. And this is less consistent. And it almost seems as if every 5-10 years there's a new way of thinking about it. Right now, this notion of the Big Rip seems to be the most consistent with the information we have, but I don't think the story is over.
Right.
I think that there's more out there.
And if heat death, like if we could step back to that one and just to make sure I understand it, because it's highly likely I don't. It's not a pendulum. But heat death is where essentially all kinetic energy or all energy turns into heat energy, and there's no more kinetic or potential to do work.
No variation. So in thermodynamics, heat will flow from the regions of higher temperature to the regions of lower temperature.
Right.
If you take that out to a natural conclusion, heat flow will end when everything is at the same temperature.
Equilibrium.
And that, I think, is what people refer to when they talk about heat death, is that when everything is exactly the same temperature, again, it's kind of boring.
Yeah, equilibrium, no ability to do work.
There's not much happening. So a lot of times I like to think about the universe as exciting because there's stuff happening. There's energy moving and flowing and momentum being transferred and stuff is happening. When everything is exactly the same temperature and you have basically, what was the word you used? Equilibrium?
Equilibrium.
Not much is happening then, right? It's pretty boring. So that, I think, is when people say heat death, they're basically saying everything becomes the exact same temperature and becomes static in that regard. And static is not interesting. I'm not interested in static. I'm interested in dynamic.
Well, I think in living systems, we always say if all of our reactions go to equilibrium, we're dead. So,
yes.
So I guess that's true for the universe too.
Yes. Thank you. I'd never heard it framed that way before, but I think that's exactly correct. I agree with that.
Yeah, because we have to constantly be taking in, processing energy, and releasing heat as a waste product, so we increase entropy in the universe, and as living organisms don't violate the laws of thermodynamics, because we only create order locally.
Is it okay if I go back to what we were talking about 5 minutes ago?
Yes. I also have one other way the universe will die that I want to ask you about, but I guess I'll let you go back.
Okay, I'll go back first, and then you ask your question. We have time, I think. I wanted to do a little bit of a difference between a gravitational open universe where the universe just expands forever and the galaxies get farther apart, but the galaxies will still stay intact.
I was going to ask that. So it's not like the Earth is going to move further from the sun as the expansion. It's just like the whole solar system, the whole Milky Way, like that would move together.
Right. But when you introduce this repulsive force associated with dark energy, that is fundamentally different. So now, yes, so the stars within the galaxies are going to separate out, and the distance between, even all the way down to the individual atoms, if you take it out to its natural extension, dark energy will cause the atoms to be driven apart from each other.
So I'm going to get wider.
Everything will get wider and bigger and farther apart. And so that's, in my opinion, even worse than this notion of just the galaxies getting farther apart. So you'd see your galaxy, but you'd never be able to see any other galaxy.
So that requires not just the velocity, the kinetic energy of motion, and the gravity. Then you have to factor in dark energy.
Yes.
Okay.
But we don't know what dark energy is yet.
Then why did you name it?
I didn't. I would have called it something like Thor. I don't know.
So the last thing I read about how the universe might be destroyed is vacuum decay. And this is something where like Higgs false vacuum breaks down. And then now vacuum decay goes faster than the speed of light. And I don't know what any of that means.
Thank you for bringing that up. Little heads up would have been good on that one.
Oh, sorry.
No, all good. No, all good. So this is delving into the quantum realm and the idea that in Heisenberg's uncertainty principle, you can violate conservation of energy as long as you do it quickly enough. So Heisenberg's uncertainty principle is often described as being like delta P delta X has to be less than or equal to H bar or whatever, and which means that you can't know precisely both the momentum and the position of an object.
Right.
But you can rewrite the equation to say that delta E delta T is less than or equal to H bar, which means that it is possible to change and violate energy. So as a consequence of that, there are, in the vacuum is not empty. Vacuum is constantly filled with particles popping in and out of existence. And so you'll have what they refer to as virtual pairs, where in the middle of the vacuum, in the middle of space with nothing else around, an E plus, E minus, a positron-electron pair can just pop into existence, and then poof, it's gone again. And for example, with Hawking radiation and the evaporation of black holes, this plays a factor in it.
Okay.
Where what happens if when you have this particle pair popping in and out of existence, but one of the particles is on one side of the event horizon and the other particle is not? Then one of the particles gets absorbed by the black hole and is gone, and the other particle is real. So now you've just had energy leaving the black hole, and the black hole evaporates. So, so there is this energy associated with the vacuum, and I don't know a lot about it, but I've read just like a paragraph. I dismissed it completely and utterly, talking about accessing the vacuum energy as a way of destroying the Earth. And presumably there might be a way of accessing the vacuum energy which would create or which would end the universe, but it's not something that I've paid much attention to or, can I be honest, care much about.
Yeah, that's fine. I can tell you that Event Horizon is a horror film from like the late 90s, early 2000s that is a sci-fi horror film about exactly things being created because of the Event Horizon, like slipping into reality, and it terrified me as a young person. I don't think it's probably good or cinematic quality, but the concept really got to me.
Yeah. Totally understand.
Yeah. So, well, at least we can rest assured that the death of the universe will probably happen well after humanity is in non-existence. So
yeah, and potentially even due to evolution, the fact that, how long have Homo sapiens been around in comparison to the minutia. So, and who says evolution is done?
It's not. So, and it's never done.
Right. So the species as we know it is not going to exist in the future.
Yeah, I like to show a circular graph of how long Earth has been around and then how long humans have been there. And it's just like this tiny little sliver you can barely see in the 4 however billion years Earth has existed. So we haven't been here that long, and we're probably not going to be here that much longer. So the views, thoughts, and opinions expressed are the speaker's own and do not represent the views, thoughts, and opinions of Lewis University. The material and information presented here is for general information purposes only. The Lewis University name and all forms and abbreviations are the property of its owner, and its use does not imply endorsement of or opposition to any specific organization, product, or service, or the universe. This podcast was produced in the WLRA podcast studios at Lewis University. Visit lewisu.edu for more information about Lewis. This has been Science Coast with Mallory Havens and
Chris White.
Thanks for listening.